Hey everybody, hope you're all doing moderately okay. So over our Thanksgiving break, we went to Missouri and visited some family, and my aunt purchased this telescope for my middle child who was really excited to get this thing. Well, he got it back to the house, and although the guy he bought it from said that it worked, the keypad would light up and backlight no image. There was no image on the screen. And with these telescopes, they are just completely useless without the electronics that drive them. As you can see, there are no longer any knobs to control this. Like, everything is done using the keypad, or the way my son does it, he's got it all finagled and wired up to the computer and uses software on a laptop. But this telescope actually wound up having a torn ribbon cable, and without the tools here that I have at this workbench and a microscope, I'm pretty well confident that the only way to fix this would have been to replace the keypad. I wound up getting into this thing and finding that the ribbon cable that goes to the display had been torn, and I'm not sure if it was torn by like prior wankery where somebody was in here messing around with it, or if it was actually this cable that had gotten pulled. But nevertheless, I got in there and just soldered jumpers across the tear and reinforced the cable, and this thing works marvelously splendid. But that's not the telescope I'm going to be fixing today, so let's go ahead and kick this one aside. So this is the telescope I'm working on today. It has a problem that is not quite as straightforward, and you'll see I've already gotten some of this all taken apart here. We've got an issue where the vertical axis is working. You know, it's going to pan up and down, but it's not capable of yawing left and right. So we're getting up and down, but no left and right. And one of the things that I found on the circuit board, of course, we had some bad caps. I replaced both of those. There were actually stress cracks in the solder joints that are for these servo plugs. So when I found that, I was like, aha, and I got in there and I resoldered everything, and that's all pretty, but we still only get one axis. You know, it'll go up and down, but it won't actually go left and right. So the next thing that I did was I actually just took and I switched these around. And after switching those around, of course, obviously, we now have left and right whenever I push up and down, but no up and down when I push left and right. So I'm thinking that somebody was having an awful lot of trouble with this thing, and that's where the stress fractures came from. And there was just overall signs of this thing being worked on before. So somebody was pulling their hair out with this. I believe I've already narrowed down the problem with this board, and I'm going to show you exactly how I've done that, and then fingers crossed, this will actually fix it. So we have the two headers here. We've got the one for the working servo motor, and then we've got the header here for the non-working servo motor. And those of you watching this channel will see just exactly how much larger this stuff is than what I normally work on. So with my meter set to diode mode and my red probe on ground, I just go through and check these pins that are on the working servo header, and you know, we get a 0.58, 0.58, 0.63. You know, I don't know what these readings are supposed to be. I do know that the middle one, you know, I know that that one I'm on right there is supposed to be ground. So what I found out is that this end pin here on the working motor, it's getting a 0.58. But if we look at that same pin on the non-working motor, it's reading an open line. You know, that's the same exact pin, and it has an open line, which is most definitely a problem unless there's some really weird scenario where that pin's not needed on one motor, but it is on the other, like in the world. So I did a little bit of pecking around on this, and I wound up tracing these two pins down to this bottom left chip right here, which is an L2930DD. If we have a look at the pinout for this suspected failing chip on the Google, we'll see that we've got 10 pins down one side, 10 pins down the other side, but uniquely enough, at each of the four corners, we have an output. So looking at this back under the microscope with my red probe on ground, you will see here I've already done a little bit of probing because I think I've already solved this. Let's look at the first output on this chip. We get a normal diode mode reading of 0.58. Our second output is over here. We are getting a normal 0.58. We have a third output, which is also a 0.58, but then we have our last output over here. That output is reading a flat open line. It's not hooked to anything, and I have traced that output down to the final pin on this connector, which is hooked to our servo motor or our whatever kind of motor it is that does not work. So to fix this today, I'm going to be using a brand spanking new IC that I bought from Mouser. Thankfully, they have these in stock. Oh, yes. Let's just go ahead and clamp this thing down into a holder. Let's see, I'm gonna go at it from that end, I suppose. To get this off the board, I am just gonna go ahead and do a little bit of flooding. I'm going to hold the temperature of the board up with a smidgen of hot air with my left hand, and in my right hand, I'm gonna be applying various different types of liquids. I'm actually hoping to get this done by the time my son gets home from school. He'll be excited to see this telescope works. All right, I'm going to use a full-size iron. This is the Hacko FM 2027 handle with the JS02 tip. And I am going to use some low melt on this today because I am unfamiliar with this board and I don't want to cause any kind of overheating. So we're just going to blob this gooey goodness all over it. And I'm going to do that on both sides. To be fully honest, I've actually not replaced one of these types of chips before at all. All right, so we've got that decently flooded with low melt, and I'm just going to kind of warm this thing up, and I should be able to pick that right up off the board any moment. It's just, oh shit, I dropped it. It's just marvelous. All right, before I get too far ahead of myself, I'm just going to go ahead and flood all of this with some leaded solder now. And we'll just wick this right on up off the board because we don't need it there. My idea, the reason why I did that is to try to get rid of as much of the low melt as I can, because I'm going to solder this by hand, just using some good old-fashioned leaded 6337 solder. It's a pretty freaking sloppy mess, so I'm going to go ahead and just clean this up with some alcohol before I solder the new one on. I'm reasonably confident that this will actually fix it because we have a solid reading. I mean, this thing is definitely open line to that pin. I have a pin out on that chip, and it's not supposed to be open line, which means I very much, most likely, have found the problem, and this will solve it. Dang it, which one was the new one? So we'll just go ahead and sit that right on the board. And thankfully, these boards got a big old bright shiny number 1 on them, so we know what pin 1 is. And that's just going to sit on there just like that. I should probably just paste it and flood it with hot air so that I'll look all fancy, but I'm not going to. I'm going to solder this down carefully with an iron. All right, so let's just go ahead and get some flux on here, nice and pretty. We're going to ignore all the Q-tip fibers. We'll just pretend like we don't see those. And that baby's going to sit just like that. All right, so switching over to leaded solder. See if we can get this to tack in place, shall we? Two. Ha 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 ha. Now I skipped these ones in the middle because they look like they might be ground or they're hooked to something big and heavy. See how my solder don't want to just flow all nice and pretty? That's because it has a lot of thermal mass, and I'm going to come back around to them with a little bit of preheating. Let's just go ahead and solder down the other side, shall we? All right, I've got the chip pretty well secured to the board now, and at this point I can use some hot air assist, which is going to help us on these big bulky pads here in the center. And also I had one up there at the end that didn't want to do real well, so I'm just going to raise the temperature up with some hot air. And now these pads that didn't want to go, they will flood. Okay. I don't want to be too crazy here because I think the solder will actually get up and all the way up these pins. So oh, there's that one, and that one. Okay, stop right there. Probably got enough solder over here already just to use. Yeah. There we go. That's got all those pins nicely stuck down. Let's get some alcohol on here and clean it up. We're just going to ignore the slight amount of burning on that connector right there. Just everybody pretend like you don't see that. So, diode mode, please. We're going to put our red probe on ground, and we're going to use our black probe to do the probing. And what is it we should get? A 0.5 something or other, right? Wait a minute, that's a 0.4 something or other. Is this even the same chip? Ooh, okay. 0.54, so the diode mode reading is actually going up as the board cools. So there you have it, folks. We have a beautifully replaced motor driver. It's not the cleanest soldering job in the world, but to be completely honest, it's probably a little stronger than the one that was on there. Each solder joint is flowed exceptionally well, and I know that's not going to come loose for any reason. I just cannot handle leaving this fuzz sitting there. Let's get that out of the way. So having a look at the other side of the chip, this thing is soldered marvelously well, but will it actually work? I'm going to say 90%. I'm almost positive this will work. So let's be very careful to line up pin 1. If pin 1 is not marked on the connector, it's often just going to be the red wire. Alrighty then, anybody want to place any bets as to whether we get smoke and fire or if we get something that works? I'm almost a little bit scared to try it. Okay, up and down. Whew, that still works. Drum roll, please. Left and right. Yes! Woo, we fixed it. I love it when stuff works out. Ah, yes. We'll be stargazing for days. Ooh, ooh, that sounded a little funky. Almost there. Now, also probably a common problem is these plastic standoff post thingies are broken out, so it's actually not possible to use the screws to put it back together. So I'm going to be using the next best thing, which is, actually no, the next best thing. I would prefer to use black tape, but I don't have any. So I'm going to be using duct tape to complete this reassembly today, at least until we know everything checks out. Then we might actually think about doing a nice proper repair and giving it some nice shiny new screws. So duct tape, good as new. And there you have it. We are fully reassembled. Some power. Ah, yes. I really like it when stuff works out. And I absolutely love that I just fixed a circuit board on a telescope using my microscope. You know, as long as you can see what it is you're working on and be able to take some basic measurements with a multimeter. Oh, and also be able to weld stuff back together. There is a ton of stuff that you can fix where other people would otherwise refer to it as the board is fried. So, it works. I love it. It works. Anyways, guys, I really thank you all for watching. If you like my video, please give me a big thumbs up. If you like this type of thing, feel free to subscribe, and I will see you in the next one. Have a good day.